So here we can start by saying that the distance between those 2 points, delta s, would be equal to the square root of the distance between the two x-coordinates squared plus the distance between the two y-coordinates squared. And this would be equal to the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. And we can say that this is simply due to Pythagorean's theorem, and we can say that then we have substitute in for x sub 1 and x sub 2, and we can say that this would then be equal to the square root. Here we have r sub 1 cosine of theta sub 1. So this would be essentially the r distance from the origin times the angle that you are making with the x-axis or the positive x-axis minus r sub 2 cosine of theta sub 2 quantity squared plus r sub 1 sine squared theta sub 1 minus r sub 2 sine squared theta sub 2 quantity squared, extend the square root, and we can then further actually multiply this out and then try to simplify as much as we can. So delta s would then be equal to the square root, and bear with me here. So this is going to be r sub 1 squared cosine squared of theta sub 1 plus r sub 2 squared cosine squared of theta sub 2 minus 2 times r sub 1, r sub 2 cosine theta sub 1 times cosine theta sub 2 plus, and I'll go to the next line. This would still be, of course, under the square root, though. Plus r sub 1, and then here we have r sub 1 squared, sine squared of theta sub 1, plus r sub 2 squared, sine squared of theta sub 2, and then again, minus 2 r sub 1, r sub 2, sine of theta sub 1, sine of theta sub 2. And so we can then combine line terms and say that the distance between these two polar coordinates is square root of r sub 1 squared. This would be multiplied by cosine squared of theta sub 1 plus sine squared of theta sub 1. And as we know that due to the trigonometric identity, this is equal to 1. So we will be able to simplify this further. Plus sine squared of theta sub 2. Again, they have the same angle, so this is going to be equal to 1. And then here we are left with essentially minus 2 r sub 1, r sub 2, my apologies, cosine of theta sub 1, cosine of theta sub 2, plus sine of theta sub 1, sine of theta sub 2. And at this point, we know that, again, cosine squared of any angle plus sine squared of any angle is equal to 1, as well as, substituting in for this here, we can say that cosine of theta sub 1 minus theta sub 2 is actually equal to cosine of theta sub 1 cosine of theta sub 2 plus sine of theta sub 1 sine of theta sub 2. So we can finally simplify and simply say that then the distance between these two polar coordinates would be the square root of r sub 1 squared plus r sub 2 squared minus 2r sub 1 r sub 2 multiplied by cosine of theta sub 1 minus theta sub 2. And we can't simplify any further than this, so this would be our final answer. That is the end of the solution. Thank you for watching.